In this video, we will learn about ways to protect metals from corroding. We will investigate how galvanizing works, what sacrificial protection is, and how effective other surface treatment methods such as painting a surface are. Let's start by having a brief look at what corrosion is. Many metals are not stable in their pure form. They tend to react and bond with other elements and compounds to become stable. For example, it is more energetically favorable for many metals to react with oxygen and water in the environment than to stay in their pure form. These types of reactions often result in corrosion. Corrosion can be defined as an irreversible destructive process where a metal is converted to a more chemically stable form by reacting with other elements. This reaction or corrosion process ultimately damages the metal or material, changing its properties, usually making it weaker. Corrosion happens first at the surface of a metal and slowly spreads to the inner parts over time as oxygen and water begin to penetrate. An example of corrosion you may be familiar with is the rusting of iron in steel. The metal loses its strength and integrity as the iron in it oxidizes with water and oxygen. This can be problematic because the rusting of iron or the corrosion of a metal affects its usefulness because its properties are changed. The specific topic of rusting is covered in more depth in another video. Now let's have a look at ways to prevent or slow down corrosion. Alloying, barrier protection, and sacrificial protection are three ways to hinder corrosion. Alloying involves mixing a metal with another metal or other elements to develop a new material with unique properties. The added elements can be carefully chosen to influence the corrosion resistance of the new material. Barrier protection includes galvanizing, painting and plastic coating, oiling and greasing, and passivation. Galvanizing involves coating a metal surface in a layer of zinc. We'll look at this in more depth in a moment. Painting, plastic coating, or coating a metal with a layer of oil or grease acts as a physical barrier to stop the metal coming into contact with oxygen and water. The problem with coating a metal in these ways is that these coatings can be scratched or washed off and oxygen and water can get access to the metal again. These methods are not very effective against corrosion in the long term compared to other methods. Passivation is the process of treating a metal chemically to decrease its surface reactivity. Metals are cleaned and then placed in an acidic passivating bath and then rinsed in oxidizing substances. This treatment forms a layer on the surface of the metal, making it more resistant to corrosion. In sacrificial protection, electrons from a more reactive metal are donated to a less reactive metal and prevented from being oxidized. Now let's turn our attention in more depth to the process of galvanizing and sacrificial protection. Galvanizing is the process of coating a ferrous metal or alloy with zinc. Ferrous refers to iron, so a ferrous metal or alloy is any metal or alloy containing iron. For example, pure iron or steel. The iron or steel part is dipped into liquid molten zinc. The part is removed from the zinc bath, allowed to cool, and the zinc solidifies, forming a zinc layer on the surfaces. The zinc coating protects the ferrous metal or alloy in two ways. Firstly, it acts as a physical barrier to oxygen and water, preventing them from reaching the iron surface. Secondly, even if some of the thin zinc layer is scratched off and the underlying ferrous metal is exposed to the air, the ferrous metal or steel won't corrode or rust, because the zinc layer gives sacrificial protection to the underlying metal. The zinc will donate electrons to the underlying metal, preventing it from being oxidized. The galvanized zinc layer only needs to be a very thin layer to carry out barrier protection and sacrificial protection. Let's investigate sacrificial protection in more depth. Sacrificial protection can be defined as the use of a more reactive metal to protect a less reactive metal against corrosion. In the case of galvanized steel, the more reactive metal is zinc, and the less reactive metal is the iron or the iron in steel. A reactivity series can help us determine which metals are more reactive than others. Potassium, at the top of the reactivity series, is the most reactive metal. This means it loses electrons and becomes oxidized the most easily of this list of metals. And gold is the least reactive on this list. The most energy is required for gold to lose electrons and become oxidized. Under normal conditions, gold is inert and is not oxidized. Now zinc is above iron on the reactivity series, which tells us that zinc reacts more easily than iron. In other words, zinc loses electrons or is oxidized more easily than iron. Little energy is needed for zinc to lose electrons and be oxidized compared to the energy needed for iron to lose electrons and be oxidized. If we enlarge this image, and if some of the zinc coating from galvanization was accidentally scratched off, or through wear and tear on the use of this metal part, it won't be a problem. The zinc will preferentially donate electrons to the iron, which we call sacrificial electron donation, and will itself react with oxygen or water to produce zinc oxide, ZnO. The zinc has become oxidized in place of the iron, or instead of the iron, and in this way the zinc protects the iron. We say zinc electrons were sacrificed for the sake of the iron. So the iron doesn't rust, but instead a hard coating of zinc oxide covers and protects the iron. What is interesting and beneficial about sacrificial protection is that a full coating of zinc is not always necessary to protect the underlying steel. Very large steel structures, such as oil rigs and ship hulls, would be extremely costly and inconvenient to try to galvanize with zinc. So instead, small blocks or bars of zinc are attached to the steel. The action of sacrificial protection from the zinc still works, even though the zinc does not cover the entire surface of the steel. Over a long period of time, all the zinc in the blocks is oxidized to zinc oxide. All that needs to be done is the zinc oxide blocks are removed and replaced with new zinc blocks. And so the sacrificial protection of the iron continues. Now potentially any metal that is more reactive than iron could work as a sacrificial protector. But zinc is both cost-effective and easily available, and so it is the metal of choice. Let's have a look at some suitable methods for preventing rusting in different applications. We've seen that alloying, barrier protection of different kinds, and sacrificial protection are the main ways of protecting a metal from corroding. Here are some specific real-life examples of where these protection methods are used. Stainless steel is an alloy, usually of iron, carbon, chromium, and nickel. The presence of chromium and nickel help prevent the iron from rusting. Cutlery and surgical equipment are purposefully made from alloys to prevent corrosion. Steel palisade fencing and steel ladders are often galvanized to prolong their lifespan. We saw that oil rigs and ship hulls are often protected from corrosion using blocks of zinc, and this is called sacrificial protection. Underground steel pipes come into contact with moisture in the ground. They are prevented from rusting by sacrificial protection, either by attachment to zinc blocks or another metal that is more reactive than iron. The barrier method of protection is most suitable for protecting steel bicycle chains from corroding. Painting won't work because the paint will flake off due to friction, and so oiling and greasing is the preferred method of choice here. But painting can be used where there is no friction, for example on bare steel fencing or over galvanized steel fencing. Soil erosion on the banks of rivers is sometimes prevented using steel gabion baskets filled with heavy rocks. Because there is much water and oxygen present, the steel would rust very quickly. To slow down the corrosion process, these river gabion baskets are often coated with plastic. What about passivation? Many steel parts in various applications that we've already discussed are also passivated. Treatment of electronic components, in other words passivation, protects their performance even though over time they are exposed to oxygen and water from the air. Now it's time for some practice. Which of the following metals could be used as a sacrificial coating on iron to prevent rust formation? A. SN, B. PT, C. Cu, D. PB, or E. Al? The answer options are tin, platinum, copper, lead, and aluminum. The question talks about a sacrificial coating on iron to prevent rust formation. When iron comes into contact with oxygen and water, it is converted or oxidized into iron oxide, which is rust. Rust is red-brown and flaky, with little strength. So iron often needs to be coated to prevent it from rusting so that it can maintain its strength. We can use a metal reactivity series to choose which metal is suitable for a coating on iron. The metals on this reactivity series are listed in order of increasing reactivity going from the bottom to the top. Potassium at the top is the most reactive metal. It loses electrons and is oxidized the most easily of all these metals. Platinum at the bottom of the list is the least reactive. It loses electrons or is oxidized the least easily. Platinum and gold are inert and unreactive under normal conditions. Under normal conditions, they are not oxidized. When a thin metal coating is placed on iron, oxygen and water are prevented from coming into contact with the surface of the iron and thus prevents it from rusting. The metal coating should be made from a metal above iron in the reactivity series. Potassium, sodium, lithium, calcium, magnesium, aluminum, and zinc are all more reactive than iron. This means they will be oxidized more easily than iron. And it means that they can donate electrons to the iron, preventing the iron from being oxidized itself. So even if some of the thin metal coating is accidentally scratched off the surface, and even if the metal iron comes into contact with oxygen and water, it will not rust. Instead, the coating is oxidized. We say the coating is sacrificial. It sacrifices or gives its electrons to the iron, and in this way the iron is protected, although the coating itself is oxidized. Of the possible answer options, only aluminum is higher than iron in the reactivity series. Tin, platinum, copper, and lead are all less reactive than iron and so cannot be sacrificial protectors of iron. So the metal which could be used as a sacrificial coating on iron to prevent rust formation is Al, aluminum. Let's have a look at the key points from this video. We learned that pure metals often react with other elements to become more stable, and this can result in corrosion. We define corrosion as an irreversible destructive process where a metal is converted to a more chemically stable form by reacting with other elements. We looked specifically at corrosion by the reaction of a metal with oxygen and water. We saw that corrosion prevention can be achieved by alloying a metal with other elements, by painting or plastic coating the surface of a metal, by oiling or greasing a surface of a metal, by passivation, which is the chemical treatment of the surface of a metal, usually with acids or oxidizing agents, and we focused our attention on galvanizing, which is the coating of a metal with a thin layer of zinc, and sacrificial protection, which is the protection of a metal using a more reactive metal.